In this set of videos, we're going to go over a few tips on building a robot and some of the concepts that are involved, and then review the types of parts that are available from VEX, and then discuss the instructions for actually building a Basebot to get started, so you'll have a robot that you can actually start driving. So we'll just start out with talking about steering. So if you've seen a car or a bike, of course, then you know that you turn the front wheels in order to steer. In this robot that you're going to build, you're going to use what's called SKID steering. So in other words, the wheels themselves, the angle of the wheels doesn't change, but you control, the speed of the wheels. If in this case, if you want to turn to the right, you would make the left wheels spin faster than the right wheels, and that will create a turn to the right. This is simple to implement. It has a drawback that it can take more power because, especially if you have high traction wheels on all four wheels, then you're going to have to, as it says, it's going to have to skid, and that you're going to have to apply more power to the wheels in order to get the robot to turn. It's going to want to just go straight. With your joysticks, you'll be able either to set up a tank drive or an arcade drive. So if the tank drive is where you have two joysticks, so your joystick on the left will control the left side wheels, and the one on the right will control the right side wheels. With an arcade, you just hold one joystick, and move it forward to go forward, move it to the left to go to the left, and the software takes care of changing the speed on the different sides, the two sides of the robot, but you'll have a choice to do it either way. Okay, so in this particular comparison here, we have a robot with four wheels, and then maybe with a robot with two wheels and a caster in the front. So in this one, it's the type that's better will depend on what you're trying to do. So if you might get involved in having to climb something or push against something, then you might probably want four wheels. You might want to drive all wheels. If you know that you're going to be on a level competition field and never really have to push anything, it might be easier to maneuver with this system where you have maybe two traction wheels and maybe a caster in front. This black dot represents the virtual turning center. So in other words, you can see that this robot with a caster on front, if you try to turn, the robot's going to, as if it's going to pivot about this point, whereas in a four-wheel drive robot with approximately equal weight all around on the wheels, it would probably pivot close to the center of the robot instead. So this slide just shows you how it might the motion might take place. In this figure right here, the tires with the squigglies on, those would be high traction tires, and then this is just the caster. And another choice might be, instead of having a caster, just to have some really slippery wheels or what's called omni wheels up front, and we'll talk about those a little bit later. The advantage to this particular configuration over this one is it's going to be more stable, right? And if you just have the one caster up front, the robot might be more likely to tip. And this just shows you some of the material that you might see if you look closely at the traction wheels. And this is similar to an omni wheel. We'll look at that a little bit more later. Okay, so here's some different wheel suggestions. If you want a lot of traction, of course, having some kind of belt or track, pneumatic tires, soft rubber tires, as opposed to plastic or omni wheels, which will not have a lot of resistance to moving to the left or to the right. And I'm going to pick up from the next video